Hello everyone, I'm Dr. Constance Goh, and I have specially created this animation to show you how a ticker tape timer works, how to interpret the markings, and how to calculate these values based on the results obtained.
A ticker tape timer has a vibrating needle which moves up and down and makes markings on a piece of paper. This piece of paper can be attached to a moving object such as a toy car or a stone that is falling, and it is pulled along by this moving object. Let us look at this simulation where I will show the needle moving in slow motion and the markings that it makes on the ticker tape. We will consider three scenarios. The first is a stationary car, the second is a slow-moving car, and the third is a car that moves faster. Now watch closely what happens when I set the cars in motion. You will notice that by the fourth dot that the ticker tape makes, the fast car is almost out of the screen, whereas the slow-moving car is only halfway through to the finishing line. For the stationary car, there was only one dot made on the ticker tape because it did not move, so the marker just kept making the dot at the same place. For the slow-moving car, the dots are closely spaced. For the faster-moving car, the dots are spaced further apart since the paper is being pulled across at a faster rate. Since the speed is equals to the distance divided by the time, for the stationary car, it did not move at all, and so the speed is 0. For the slow-moving car, since the distance between each dot is smaller, the speed is also lower. And for the fast-moving car, since the distance between each dot is greater, the speed is also higher. Let us now interpret the ticker tape markings for various scenarios. As we have learned, in the first scenario, the car is moving slowly. And since the distance between each marking is constant, the car is moving at a constant speed. For the second scenario, since the spacing is wider, the car is moving faster, but it is still moving at a constant speed. In the third scenario, it can be seen that the spacing between the markings are getting smaller and smaller. Therefore, the car is moving at a decreasing speed, or we can say that the car is decelerating. In the last scenario, you will notice that the markings look exactly the same as those in the third scenario. However, the car is traveling in the opposite direction. So it is very important to take note of the direction of motion of the object when you are interpreting the ticker tape markings. In the fourth scenario, it shows that the spacing between the markings are now increasing. Therefore, the car is moving at an increasing speed, or we can say that it is accelerating. Let us now calculate the speed of the car. When the question tells you that the needle of the ticker tape timer is vibrating at a frequency of 50 Hz, they are telling you that this needle is moving up and down at a rate of 50 times per second. And therefore, the time taken between two dots on a piece of paper can be calculated by taking 1 second divided by the frequency of the needle. In this case, it will be 1 divided by 50, and the time is 0.02 seconds. Now do take note that the time between each marking is constant at 0.02 seconds, regardless of the spacing between the markings. When we want to calculate the instantaneous speed of the car, this refers to the spacing between the two dots divided by the time taken to travel that distance. So, in this example, it can be either A, B, or C divided by 0.02. However, if you want to find out the average speed of the car, this is defined by taking the total distance divided by the total time. In this case, the total distance traveled by the car is d, and since there are 7 spacings from the first to the last dot, the total time taken is 0.02 times 7.
I hope that you have found this video useful. Do check out the other videos on my YouTube channel. Meanwhile, do continue to explore and experience science. See you again.